7.2 Similar polygons. The objective in this lesson is to identify and apply similar polygons. We are going to use ratios and proportions in this lesson, very important. Start with some vocabulary here. Similar figures have the same shape, but not the same size. And similar uses the symbol this. Notice that it is a lot like our congruent sign. Congruent, let's find a different color here. Congruent, that means the same, right? Equal. Congruent is equal and similar. So congruent means they have the same shape and equal size, whereas similar figures do not have to have equal size. Our key concept here, definition, similar polygons, corresponding angles are congruent and corresponding sides are proportional. So, definition of similar figures. Corresponding angles are congruent and corresponding sides are proportional. What's a proportion look like? A fraction equals a fraction, right? We compare two figures. So let's look here. We are told that quadrilateral ABCD is similar, that's read as similar, is similar to quadrilateral GHIJ. Now, just like in our congruent statement, a similar statement uses corresponding vertices in order. Okay, so what this says is who's in first position? A and G. So angle A and angle G are congruent. Angle B, angle H are congruent. Angle C, angle I, angle D, angle J, those are congruent. Now we are told that our sides are proportional. So it goes through just like we had congruent sides in congruent figures, we have proportional sides in similar figures. So who's our first side here? AB. And who's our next side? GH. Those sides are proportional. So I can write AB is compared to GH. The length of AB is compared to the length of GH. And who's our next side? BC. And who's next here? HI. BC, length of BC compares to the length of HI. And then CD and IJ. And finally, AD and GJ. So we can write these in what we call an extended proportion, which says that the sides we are comparing are all proportional to each other. Because if I compare AB to GH, then it's going to have the same ratio as BC to HI. We call this, and this is worth some stars here, words we are going to use frequently. We call this a scale factor. And a scale factor is the ratio of corresponding linear measurements. What does linear measurements mean? Corresponding sides. A scale factor is the ratio of corresponding sides of our two similar figures. Now, how does this work? Well, let's look at our example here. We are told that triangle ABC is similar to triangle XYZ. So we know that our angles are congruent, and look, our angles are in order here. A and X, B and Y, C and Z are congruent, and our sides are proportional. So if we look at side AB, who does it compare to? To XY. Well, what's the length of AB? 15. Length of XY is 6. We reduce, divide both by 3, we get a 5/2 ratio. And who's next? The length of BC compares to the length of YZ. That's 20 is to 8. And we reduce, divide both of them by 4, and I get 5/2. And who is our last side here? AC compares to XZ. That's 25 to 10. Divide both by 5, 5/2. Notice how everybody, all of our corresponding sides, have a 5:2 ratio. This gives us a scale factor is 5:2. Now I like to number my figures, figure 1, figure 2, figure A, figure B, whatever, so I can keep track of them. Because if you noticed, we always put figure 1 on top, figure 2 on the bottom. If we started out with figure 2 on the top, we'd have to keep figure 2 on the top, and we'd have a ratio of 2 to 5 from figure 2 to figure 1. It's a 5:2 from figure 1 to figure 2. So that's how we find scale factor. What that says is for every 5 units on figure 1, we count 2 units on figure 2. It's just a scale. How much bigger or smaller do we make it? Well, let's look at how this works. Our first problem here. We are told that triangle MNP is similar to triangle SRT. We are asked, what are the pairs of congruent angles? Well, they're just in corresponding parts. M and S, N and R, P and T. And then what is the extended proportion for the ratios of the corresponding sides? Well, we just write our sides in order, and I like to make this figure 1, figure 2. We're going to put figure 1 on the top, figure 2 on the bottom of our ratio, and then it's just corresponding sides. First and second position is MN, first to second, SR. NP, RT, MP, ST. Okay, it's your turn. Pause the video and do the next problem. That was a fun problem. We were told that figure DEFG is similar to figure HJKL. So similar tells us that corresponding angles are congruent and corresponding sides are proportional. It's a definition of congruent figures. First, we are asked what are the pairs of congruent angles. You could have drawn a picture if you like. You don't have to, because it's just position 1 to position 1. So DH, EJ, FK, and GL would be our corresponding angles. The second question is, what is the extended proportion for the ratios of the lengths of the corresponding sides? So I simply numbered figure 1 and figure 2, and then I decided to put figure 1 on the top, figure 2 on the bottom, and I just went through. My first side is DE. On the second figure, my first side is HJ. Position 2 to 3, EF, 2 to 3, JK, FG, KL, and then D to G, coming back around, and, oh, not paying attention here, D to G, and H to L. There we go. So this is very much like our congruent figures. It's just our sides are not congruent, our sides are proportional. And they are proportional by a given scale factor, a ratio. Now, we can use this to go the other direction. Are the figures similar? So, are our polygons similar? How do we know if they're similar? If they're similar, our angles will be congruent and our sides will be proportional. And these must be corresponding. That's important. So let's look at our angles first. It doesn't matter where we start. I'm going to start here at angle M just because it looks like a good place to start. It has one congruent mark. Well, so does angle W. And then I'm going to move to the angle 2. And I move to angle 2. So far we're looking good. And then I keep going around. There's my right angle. If I continue on in the same direction, do I get to a right angle? Yes, I do. And then as I move down the figure, I get to a 3-angle mark. As I continue on with this one, I get to a 3-angle mark. And that connects back to our 1-angle mark. So our corresponding angles are congruent. So check. Now we have to determine, are the corresponding sides proportional? And again, this is why I like color. So we've got, I'm just going to say figure 1, figure 2. We're going to put figure 1 on top, figure 2 on the bottom, which is what we decided. So here we're going, they start out with JK, blue to purple, and blue to purple is TU. So that's a 12:6 ratio. It's a 2:1 ratio. All right, that sounds good. Now I need to do my next side. And so let's go K to L. That's 24. K to L would be correspond to U to V. Okay, so 24:16, that's a 3:2 ratio. We could stop right now because these two ratios are not the same. But let's continue on and look at it. L to M is V to W. It's a 24:14, which is a 12:7. So definitely not similar at this point, right? And J to M is T to W. It's a 6:6. It's a 1:1 ratio. So your corresponding sides are not proportional, which means your polygons are not similar. This is a big no here. As soon as one of your scale factors does not match, you're done. They are not similar. All right, let's look at the next one. Are these two similar? Is ABCD and EFD similar? Well, first let's check our angles. Let's find our congruent angles. So start with A. Who's A compared to? D. All right, and then we move on to B. Who's B? B is E. And then we would go B to C, and E would come over to F. So our order here, A matches up to D, B matches up to E, and C matches up to F. those would be our corresponding congruent angles. So we're going to use this. Here's figure 1, here's figure 2. And I'm going to do A to B compares to D to E. So what are my measurements? 12 to 15. I get a 4 to 5 ratio. Then I'm going to go B to C compares to E to F. It's a 16 to 20, which is reduces to a 4 to 5 ratio. And A to C is the same as D to F, and 8 to 10, which is a 4 to 5 ratio. Look at all of these. They are the same. So yes, we can write a similarity statement. And we already put them in order with our angles. That is a really good way to start. So I can just go triangle ABC is similar to triangle DEF. And what is our scale factor? Well, what is the ratio of all of our corresponding sides? We have a 4 to 5 ratio. So our scale factor is 4 to 5. And you can write that in any of our ratio ways, as a fraction or with the colon or with 2, 4 to 5 ratio. And once again, it's your turn. Go ahead and pause the video and work out the next 2 problems. Some really fun stuff happening in these problems. We were asked to determine if the polygons are similar. If they are, write a similarity statement and give the scale factor. So on the first one here, we had a bunch of right angles. So how do you determine if all your right angles are congruent? We know that. All right angles are congruent. So how do we determine which sides are corresponding? Well, we have, on our first figure here, we have a long side and a short side. So the only possible option on figure 2 here would be to match up the long side to the long side and the short side to the short side. So that's what I did, and notice I'm using my color good, and I got a 3 to 4 ratio and a 2 to 3 ratio. So my sides are not proportional, my figures are not similar. But now on the second one here, and color definitely helpful here, I decided figure 1, I'm just going to start at A. And I checked my angles. Do I have the same angles? A is S, B is R, C is V, D is U, E is T. So my angles were in a good order. So I'm good to go there. And then I'm going to determine if my sides are proportional. So I didn't write down that my angles were congruent. My corresponding angles are congruent. Check. Because you kind of have to do that. And so then I just went around my figure and compared my the ratios of my sides. So on the first one I went A, B, C, D, E, and our angles told us that that would be S, R, V, U, T. And I compared my sides, and look, I got a 2 to 1 ratio on every one of them. So my angles are congruent, my sides are proportional, so yes. And now all I have to do is write my similarity statement, which is the order that I determined with the angles, and then my scale factor is the ratio of my sides, 2 to 1. Problem 3 is just another example of this. We are told that figure ABCD is similar to figure EFGD. we want to find missing values. This is where our proportions are going to come in handy. The first thing I'm going to do is separate these figures. So A, B, C, D, D, A, B, C, I'm told is similar to E, F, G, D. So there's D, E, F, G. And I'm going to label my corresponding sides here. So how long is AD? That says it's 9. Who does that correspond to? That corresponds to ED, which is 6. And then AB is 5. Who does that correspond to? Y. And FG, or BC, is 7.5, which is FG, which is X. So those are my corresponding sides. And I know that my corresponding sides are proportional. So I need to find two sides that both have numbers. And right here, this side and this side have numbers. So we can call, well, it looks like they do. This is figure 1 and this is figure 2. Or we could do them backwards and put 2 on top and 1 on the bottom. So then what I do is I write a proportion. And I'm going to move that here where I have some space. Write a proportion. We're going to put figure 1 on top and figure 2 on the bottom. So I find the two sides where I have numbers. That's a 6:9 ratio. And now I want to find the value of x. Well, where does x go? X is in figure 1, so it goes on top. And who corresponds to that? 7.5 on the bottom. Look how nicely we have a proportion written here. And then we just cross multiply and we end up with x equals 5. So we could go over here, say that side is 5 units long. And it's time for you to pause the video and finish this problem. That was easy. I wrote my fraction bar equals fraction bar. I decided I wanted figure 1 on top, figure 2 on the bottom. I used known numbers. So I know that they are in a ratio of 6:9, just like we used up above. And then y comes from figure 1, which corresponds to 5 in figure 2. Cross multiply, I got y equals 3.3. Now we also could have done this. If we put figure 1 on top, 2 on the bottom, are there other numbers that we know? Well, we just figured out x is 5 and 7.5, and it would still be the same here, y and 5, and we would have gotten the same answer. You cross multiply and do the math, and you would get the same answer. So you just use a known scale and then find your unknown using proportions. I told you before, proportions are awesome.